x. You see this little red light on here? That means the battery supposedly, even though I charged it all night, is okay. So in this graph, they give us the graph of g of x, and unlike the ones that we've done before, g of x is just some random bunch of lines stuck together. So we don't have an idea of what equation this is. We just know that this is g of x, and we have it in function notation. So we want to sketch the image of the graph after each translation. So A is a translation 4 to the left, and B is a translation 1 unit up. We want to write the equation in terms of g and state the domain and range of each function. So I'm going to, again, color code things here and do A in blue and B in green. And so in A translation of 4 units left, well, you just can take these 4 key points and move them 4 to the left. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and play connect the dot. Oh, I like connecting the dot. There's just something fulfilling about that. And we have the same graph moved 4 units to the left. Similarly for the green one, we can move it 1 up, move this point 1 up, this point 1 up, this point 1 up, play connect the dot. And so the graphing part, based on the description, is really easy. What's going to be a little bit tricky here is this statement. And one of the key things that you're going to have to pay attention to in a math class, and in any class in particular, is the instructions and the wording. Because sometimes when you're in class, you just wait for the teacher they say the instructions, and then you wait, and the teacher does it, and then you go, okay, I can do that, right? But you get to a quiz or a test, and then you don't have the teacher there, and all you have is the instruction, and you're like, I don't know what that means. Because while you're in class, that's a moment where you just sometimes decide not to pay attention because you know the teacher's going to do it in a second anyways. And I'm going to really highlight some of those instructions and some of that vocabulary where you are going to get confused later on. So that you pay attention the first time, and then all of a sudden it makes it better for you later on. And in this case, it's this part here. In terms of the function g. Sometimes you're going to get questions that say in terms of x. Sometimes it's going to say in terms of the function g. What does that mean? The other word I'm going to underline here is the word equation. An equation has an equals sign. So for A, we want to write an equation of our blue graph in terms of the function g. So because it's an equation and because it's a graph, we're going to start with y equals. And whenever something says in terms of, that means on the right-hand side of your equation, you need to have that. So when it says in terms of the function g, I need the function g on the right-hand side of my equation. Now, g of x is this red graph. How is the blue graph related to the red graph? Well, we already know it's been moved 4 units to the left. How do we show that in function notation? Well, moving left and right is something that happens inside of a function. And if my function is g and I need to write it in terms of g, I need to show something happening inside of that function. How do we show 4 to the left? Well, we're going to have an x and a 4. What's the sign going to be in there? Is it going to be a plus or a minus to go to the left? It's going to be a plus. Again, what happens inside of the function is kind of opposite of what you think. Like you think going 4 to the left, you think minus 4, but it shows up as a plus 4. So that is in terms of the function g. Same thing in part B. In terms of the function g, here we've moved it up 1 unit. It's an equation, so we'll have y equals, and up happens outside of the function. So we would have our function g of x, and then we would show plus 1 afterwards. The last thing this question asks is to state the domain and range of each function. So for our first one, I'll just put a D here for domain. Domain are your x values. In this case, our smallest x value for our blue graph is at -5, and our biggest x value for our blue graph is at 2. I'm going to start by showing set notation. Now with set notation, that's where you use the greater than or less than signs. So to do this, in the shortest form possible, we would say that the domain of the blue graph is between -5 and 2. So we would write -5 less than or equal to x, less than or equal to 2. And that would be accepted as sort of a shorthand form of set notation. Proper set notation, just to show you proper set notation, would start with these fancy squiggle brackets and go, the domain would be all x values, and we can learn some fancy math words. Does anybody know what this symbol means in math? It means such that. All x values such that -5 is less than or equal to x is less than or equal to 2, comma, where x belongs to all the real numbers, and then end with that fancy squiggle bracket. It's really long, okay? Okay? What do you need to write? You just need to write the shorthand version. However, sometimes in multiple choice questions or in just short answer questions, sometimes a long version shows up. If you've never seen a long version, it immediately scares you to skip the question and go on to the next one. It's not that bad. It just has a bunch of extra stuff that you don't need. It's like French. French has like 15 letters at the end of the word you don't have to say, right? They just add it there to like make spelling bad. I don't know. So that is set notation for the first one. All you need to do is the short version. For the second one, for the range, well, range are your y values. What's our smallest y value? It's 2. What's our biggest y value? It's 5. So we would say 2 is less than or equal to y is less than or equal to 5. And if you wanted to, you could do the long y such that 2 is less than or equal to y is less than or equal to 5, where y belongs to the real numbers. Squiggle bracket to end. And what that means when you put 2 less than or equal to y less than or equal to 5, it means it includes every value starting from 2 and going up to 5. Like 2.2 and 3.8791, all of the values that are possible in between are included. In part B, I'm going to do the domain and range, but we'll use interval notation. Interval notation says the same thing in a shorter way. If my domain for my green graph has a smallest value of -1 and a largest value of 6 and includes every x value in between, in interval notation, we would write it like this. We write our smallest value on the left, saying it starts at -1. We write our largest value on the right, meaning that it ends at 6. The square brackets indicate that both -1 and 6 are included. Did you ever do domain and range questions where one of the values wasn't included in a graph like this? Do you remember what you had to do? What would I have to do on the endpoint here so that 6 wouldn't be included? How would you show that? An open circle, right? That would be, then I would change this to a round bracket. Okay? But right now this circle is filled in nicely. And so we have the square bracket. So with interval notation, you're looking for what's the smallest value, what's the biggest value. So for our range, when we're looking at our y values, what's our smallest value of y? Coming from the bottom, it's 3. 3 is included. What's our largest value? It's 6. So our range is from 3 to 6. After we're done a question, what's going to happen is I'm going to say, you've done question 1. Now in your homework, you are now able to do the following questions. So in this case, it's 4 to 7. And this will be your homework assignment. Again, I'm not taking in your homework assignment, but you need to make sure that you practice so that you know how to do things. And what I'll often do, and today I'll do it as well, just so as we're getting used to things, is I'll give you about 5 minutes to work on this. It won't be quite enough time to finish, but it'll be enough time to get started. So the homework is right at the end of our notes. It starts on page 169. The nice thing about your homework is you don't have to flip right to the end of the book to find the answers. Your answers are right after the homework section, so that is on page 176. So we'll take some time to work on those right now.